Hello, I welcome you all in this video where we just doing a recap of our previous video. So we talked about the reactivity series yesterday, and I gave this mnemonic posokamazifetu H comescopt, which actually was making things easier for us. Okay, so we have these metals. So today we're going to go into the extraction of metals, and today we'll definitely look at the extraction of a metal called aluminium. But okay, before we go there, so like I said yesterday, all the metals that are, you see carbon here is placed here for a reason. Like I mentioned yesterday that this carbon here, it is placed particularly here for a reason, in that the metals that are above carbon here, all these metals, aluminium, magnesium, sodium, calcium, barium, potassium, lithium, all these metals, they can only be extracted by electrolysis. Okay, they can be extracted by electrolysis. In the metals below carbon, you can extract them using reduction method using coke, which is carbon itself. In the metals that are below hydrogen here, sometimes you just use thermal decomposition or other methods, because these they're very unreactive, so it's not difficult to extract some of these. Okay, so without wasting time, let's go into the extraction of metals, starting with aluminium. Okay, so extraction of aluminium from bauxite. So this bauxite, it is simply the ore, okay, the ore that contains aluminium. So when you think about this ore, you think of it in the case of, it's more like a rock, okay, that is found in the earth's crust. Okay, in the earth's crust, that is what we get, okay, in the earth's crust. And from the earth's crust we obtain this bauxite. After we get the bauxite, we then get aluminium from it. Okay, so what's the chemical name for this bauxite? Okay, so bauxite's chemical name is aluminium. It's called aluminium oxide. Okay, it's called aluminium oxide. Okay, and then the chemical formula is aluminium. This comes from the oxide, so it's called aluminium oxide. So this is the chemical name for bauxite. So what we want to get from bauxite is to extract what? Aluminium from what? From this bauxite. Okay, we are trying to extract aluminium from bauxite. So we're going to see that aluminium is actually here. So the method of extraction is what? Electrolysis. Electrolysis is quite an expensive process to be done when extracting this. So all these metals above, they are supposed to be extracted using aluminium. Okay, not with an electrolytic cell, and we are going to see how that actually happens. Okay, so what are we saying? Bauxite is first purified to produce aluminium oxide. Okay, so we said once you purify the bauxite, you're going to get aluminium oxide, and aluminium oxide is now where you're going to extract your aluminium. So aluminium oxide is then dissolved in molten cryolite. Now, why do they have to dissolve this aluminium in molten cryolite? So here's the reason why. So aluminium oxide, it has a very high melting point of about 200 degrees Celsius. And to have that amount of heat, okay, 200 degrees Celsius, that would use a lot of energy, and it's very expensive. So in order to lower the melting point, so the main reason why we're using a cryolite here, the only reason why cryolite is being used here, it is simply to lower the melting point. Okay, if I'm not mistaken, this cryolite is actually sodium Hope I get this right. Sodium, aluminium, I think it's something like this. That's the chemical formula for this cryolite. I'll have to look up that. Okay, counter check it again, the chemical name for cryolite. But the main important thing is that the use of this cryolite, it's simply to do what? To lower the melting point. Okay, so it can simply lower the melting point. Otherwise, if you simply use pure aluminium oxide like this, it would require you to have a lot of energy of about 2000 degrees Celsius just to melt this aluminium oxide, because we want it to be in molten state. Okay, so what happens now, if we are following the order, we are saying that bauxite is first purified to produce aluminium oxide, and then after that this aluminium oxide is dissolved in molten cryolite. Okay, and we've explained why they dissolve it in molten cryolite is simply to lower the melting point. So cryolite can simply lower the melting point without interfering the rest of the reaction. Let's see how that is happening. Okay, so let's look at what is actually going on in this electrolytic cell. So this whole diagram is called an electrolytic cell. This is where electrolysis is taking place. Okay, so we call this an electrolytic, or electrolytic if you so wish, electrolytic cell. And in this electrolytic cell, this is where the whole process of electrolysis will take place. So we are told aluminium has been dissolved in the molten cryolite. Okay, so aluminium will occur in its molten state. Now, what is molten state? Molten state, this is when a solid has been dissolved into a liquid. Then we say that it's in molten state. Okay, so this aluminium now is placed inside. Okay, so this liquid you are seeing here is purified aluminium dissolved in molten cryolite. So this is the mixture that is added here, containing aluminium oxide and cryolite. Okay, so it's already been dissolved. Here you can see that it's in liquid state. Okay, so now what will happen is that the outer casing of the electrolytic cell is made up of a casing which is made of steel. Okay, and we'll go over that, why they have to use steel in this casing. And then after that you have graphite. Okay, this is called the graphite cathode. Okay, so cathode simply means that it is negatively charged, and then they place the positive graphite, the anode. Okay, anode, it's positively charged, so they place the cathode here below. Okay, and I'll explain why the cathode is placed below like that, and then why as well the anode is placed on top. So all we need to know is that the cathode, which is the graphite, is negatively charged, while the graphite anode is positively charged. Okay, so let's go further and explain. So we are saying that this mixture here, okay, we have pure aluminium, we have pure aluminium oxide. From this aluminium oxide we have two things. Okay, we basically have two things here. Okay, we have two things here. You have aluminium and the oxide here. So here's what will happen. These are the things that are taking place inside this electrolytic cell. So once this is in molten state, okay, it's in molten state, so this one forms its ions. Okay, aluminium will form its ions, and aluminium forms positively charged ions. Okay, aluminium happens to be in group 3, so it's going to carry a +3 charge. Okay, and this is actually oxygen, which is going to carry a 2- charge. Okay, so metals always carry positive charged ions, and aluminium carries, non-metals carry negative charges. So this is oxygen. So what will happen now is this. So these things are already in molten state. Okay, and they separate, forming these ions while in this same state. So what will happen is, since this is positively charged, it's going to get attracted to the negative. Remember, when you have positive and negative, here there's an attraction. Okay, so this negative cathode is going to attract the aluminium ions. Okay, so you have aluminium ions getting attracted. Okay, so you have aluminium ions. Let me try to use something that is of color, maybe black. Okay, so you have aluminium. Okay, let's see, aluminium positive ions carrying a positive 3 charge. So these will get attracted towards this this negatively charged cathode. Okay, and then what happens, the O2, they will get attracted to the positively charged anode. Remember the laws of science. Okay, laws of attraction is a negative attracts to the positive, a positive attracts to the negative. So this is what will happen. That's why you see that what is settling down here is actually molten aluminium. So now how does this molten aluminium change now from its ionic form to becoming aluminium? So here's what will happen. This cathode is negatively charged. So what will happen is that this aluminium, here's the reaction that will take place. So aluminium with its positively charged ions, okay, I should have maybe just put them like this. So it has these charges here. So the cathode will give it, the cathode here is going to give it three electrons. Okay, it's going to give it three electrons. Okay, so now imagine these electrons, they are negatively charged. Okay, so just to illustrate what will happen here, you have, let's work out the charges. So you have 3 positive charges. Okay, 3 positive charges, then you add 3 negative charges here. You add negative charges 3. If you're good at mathematics, this will be 3 minus 3, and you get 0. Okay, so this cancels out the charge on aluminium, and at the end of the day you have molten aluminium. Okay, you have molten aluminium. So this is what is happening here at the negatively charged graphite, which is the cathode. Okay, it's going to donate these. Okay, then what will happen here at the positively charged cathode? So this has been attracted there. So at the end of the day, you are going to find that you have this negatively charged oxygen here. So what will happen is that it's going to lose 4 electrons. Now it must give out at the end. We know we want to get oxygen. Okay, oxygen is O2, so to balance up we are going to put a 2 here. So let's work out the charges. You see what is happening here. So 2 negative charges times 2, that will be, you have 4 negative charges, minus, okay, minus again here 4 electrons are negatively charged, so you say minus 4. Okay, negatively charged. Again, if you can just work out simple mathematics here, that will be plus 4, and you get 0. So that's the whole essence here. You need to have 0. Okay, so here we had 0. Okay, these don't have any charges, and the charge is 0. So this is the thing that's happening here. Okay, I mean here at the anode. Okay, the graphite anode. So now this aluminium, the molten one, will simply come out here, and it's then collected. But what happens to the oxygen? So remember, graphite is simply carbon. Okay, graphite is simply carbon, and what will happen is that this carbon will then react with the oxygen, and once this reaction takes place, it will give out carbon dioxide. Okay, to give out carbon dioxide, and these are the things that are taking place, and this is very high yield information, and you have to understand how everything is taking place and be able to explain. Okay, so that's how the molten aluminium is extracted. Okay, so here aluminium has been extracted, and it will go through several stages. Okay, so let's move further. I hope that is understood. So now the overall reaction, we started with bauxite, aluminium oxide, okay, O3, and the end products, we're just going to pick the end products, aluminium and oxygen. Okay, aluminium plus oxygen. Then here we just want to balance the equation by putting a 2 here, then here a 4, and here 3, and I think everything is balanced. Right, so this is the overall reaction that is taking place in this electrolytic cell. So that is how aluminium is extracted from graphite. Okay, we've explained quite a lot of things. We were talking about extraction of aluminium from bauxite. We went over to explain how everything is added and the reactions that are taking place at the cathode. So this one is taking place at the cathode, and then the reaction that takes place at the anode is this one. Okay, so with that said, if there are any questions, you can leave them on the comment section. We'll get to them. So in our next video, we'll be talking about the extraction of iron from its ore.